All right, this is part 2 of the law of sines. Today we're going to talk about that thing I mentioned in the last video called the ambiguous case. I have a nice little demonstration of it. If you want to Google AAS ambiguous case GeoGebra demo, go for it, and you can see that animation because I really struggle to draw it. But let's go right into this. Anytime you're given side-side angle, see what I did there? I didn't write out the naughty word. If you're given angle A, okay, realize we could switch all these letters to match what we are given. If we're given angle B or angle C, switch all the A's to B or C, switch all the C's to whatever other side, okay? So if side A is greater than the other side you're given, okay, you're given an angle, the side across from it is greater than the third side, or the second side. There's only one triangle, don't worry about anything. If it's less than the other side though, so if I tell you my angle, and I say this side is 5 and this side is 12, that's when we need to find this magic number called h. We find h by taking c times the sine of angle A. That'll give us a height, right? Because angle A, if I make this a right triangle, sine of A is h over c, so h is equal to c times the sine of A. If that value of h is bigger than our value of A, there's no triangle. That means this side is too short. He's just kind of dangling in the wind. He will never make that triangle. If h is equal to A, then you have one triangle and it's a right triangle. But more often than not, h will be smaller than either of the two sides you're given, which means there are two possible triangles. These two triangles are the outer one or this inner one. Those both have that angle, that side, and that other side that you were given. So if you have two triangles, solve the first triangle as normal, no changes there. To find the second triangle, you're going to take 180 minus the angle you just calculated, and then solve the rest. A special note, if the angle for the second triangle plus A is more than 180, then that second triangle doesn't actually exist. So you don't necessarily have to check this every time, because you could just do the math and see if the second triangle could exist. So let's take a look. I'm giving you angle A is 30 degrees, side A is 6, side B is 7. Now side A could be one of those two places. So we start by setting up the law of sines. The sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. Obviously here, I have to solve for angle B first. So I take the sine of 30 degrees over 6 equals the sine of B over 7, cross multiply, 6 times the sine of B equals 7 times the sine of 30, divide by 6. I get the sine of B is equal to about 0.583 repeating. So angle B is equal to the sine inverse of 0.583 repeating. So I got that angle B is 35.685 degrees. Now if I'm ignoring the ambiguous case, I keep going, right? I say, okay, that means angle C is 180 minus 30 minus 35.685, which means angle C is 114.315 degrees. And then I can dive into side C. Go back to my anchor. Right? Cross multiply. Divide by sine of 30. And we get side C, which is about 10.936, no labels. So remember, 3 pieces go into this answer: angle B, angle C, and side C. Now let's take a look at what we're given. We were given a 6 and a 7. The 6 is across from the given angle. That is less than the other side we were given, which means we have to find h. All right? H is equal to this other side we were given times the sine of our angle. So h is 3.5. H is less than both of those, which means that there are 2 triangles. So we just found one of them. To find the other, we take this first angle we found. You do 180 minus that number. That means that this angle B would be 144.315 degrees. We'll find angle C the same way, 180 minus 144.315 and 30. In this case, angle C is very small. It's 5.685 degrees. And then we go to our anchor. Sine of angle A over 6 equals the sine of angle C over C. Cross multiply. So side C is 189. So very different triangle over here, but they could both be the real triangle. Let's try this one. This one doesn't give us a picture, which most law of sines problems won't, or law of cosines ones. So I draw one. Remember how I said my pictures always look the same? There we go. Label what I know. All right, now my side across from the angle is smaller than the other side. According to my rules, that means I have to find h. H is the other side times the sine of the angle. H is 663.474, which is smaller than the other side, which means we have 2 triangles. All right, start by law of sines. The sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. We have to find angle B first. So we're just going to cut off that last fraction and cross multiply. And then divide by 697. So the sine of angle B is about 0.952. To get angle B, we take the sine inverse of that. So in our first triangle, angle B is 72.157 degrees. Now at this point in time, if I hadn't done all this work with h, I could find out if there's 2 triangles. I would just say, okay, 180 minus that is 107.843. So if angle B was that, could I get an angle C, right? 107.843 plus 48.2 is only 156. So I could actually subtract from 180, and angle C would still be 23.957 degrees. If I'd gotten like a negative value for C, I'd say, oh, I guess the second triangle doesn't exist, if you don't feel like finding your H value. So let's go back to our first triangle here. Let's find angle C. We'll just take 180 minus the 72.157 and the 48.2 we started with. Angle C is 59.643 degrees. And then we'll set up our proportion. Go back to your anchor, which is the sine of 48.2 over 697. And use C as sine of 59.643 over C. Cross multiply. C times the sine of 48.2 degrees equals 697 times the sine of 59.643 degrees. Divide by the sine of 48.2 degrees. And our missing side C is 806.782. I don't have any labels, so I've got my two angles and my side for that triangle. Then I still have to solve the other triangle. Remember, I already got the two angles there. So I would just set up the sine of angle A over side A equals the sine of my new angle C over my new side C. Cross multiply and divide just the same. C times the sine of 48.2 equals 697 times the sine of 23.957. Divide by the sine of 48.2. I get that side C is 379.647. So for my other triangle, quite different measurements. There we have it. So this problem says solve the triangles. We're just going to calculate how many triangles there are. First thing to notice, we are given angle, side, side. I always like to draw myself a picture. Label everything I know. All right. The side across from the angle is smaller than the other side, means we have to find H. H is the other side times the sine of my angle. So in this case, H is approximately 51.731. Now, according to my rules, if H is bigger than the side I was given, which is across from the angle, then there is no triangle. All right, let's set up this next one. Again, I like the picture. The picture helps me think. Angle C is 52.3 degrees. Side A is 32.5. Side C is 59.8. All right, we start off with looking at the side across from the angle and my other side. The side across from the angle is bigger than the other side. Well, that means I don't worry about ambiguous case. And there's one triangle. And let's try one more of those. Again, I would draw myself a picture. Label everything I know. All right, the side across from the angle is smaller than the other side, which means I need to find H. H is the other side, which is 8.61, times the sine of my angle. So H is 4.279. That is smaller than both of these sides I'm given, which means there are 2 triangles. We've got some practice we will do on this.